We are on the review sheets for lessons 9.1 and 9.2. And we're starting on 9.1a. So we're going to look at the function f of x equal to 3x squared, part A, complete the table below. So when you see this table, your first instinct might be to say, I need a graphing calculator to do this, but that's not true. These are the x values, and we're just plugging them in. And so you can individually plug them in. Don't even necessarily need a calculator. X squared, you plug in -4, -4 squared, positive 16, right? -4 times -4. And then times that by 3. 16 times 3 is 48. Plug in -3 squared is 9. 9 times 3, 27. -2 squared is positive 4. 4 times 3 is 12. -1 squared. -1 times -1 is positive 1. Times 3 is 3. 0 squared is 0. Times the 3, still 0. Positive 1 squared is going to be the same as -1 squared. So 1 times 1 is 1. Times 3 is 3. You'll notice same thing on both sides of the 0, 0. 2 goes in. 2 squared is 4. And 4 times 3 is 12. And you start to see the mirror image. So 3 squared is 9 times 3 is 27. And so we can start to see this is going to be 48. Now, let's say for a second you wanted to do this in the graphing calculator. You have access either to a handheld or you downloaded the one on the computer. Let's take a look at what that looks like. So if I wanted to make a table to fill this in, I would go to my y equals, and I have to put in the function 3x squared. And then I'm going to go to my table. So second, and then hit the graph button because table's up above it. And here's my table. And you could scroll up and down if you needed to see more, if yours wasn't set up to start at -4. But you can see here's our 48, 27, 12, 3, 0. Okay, if you want to take a look at what the graph looks like, you can click it. But when we graph the equation here on our papers, we have to be exact. So we're going to use the actual points that were given to us. Obviously, this is going to be a parabola. So this graph here isn't necessarily going to help you sketch the one on your paper. So let's go back to that. So what we're going to do is just take each one of these points and put them on there. I'm actually going to start in the middle. Okay, remember this is called your vertex. So 0, 0. And just a quick heads up, not every parabola has a vertex at 0, 0. It's just the ones we're looking at, the most basic ones. That's where you're going to start at. These can move all over the place. And when I go to 1, it's at 1, 3. These are counting by 6, so 3 would be halfway up, so I'm going to be right here. And when I go to -1, it also goes to 3, so it's right here. Positive 2 gets me up to 12, so right on that line. -2 gets me to 12. 3 gets me to 27, so 27 is going to be between 24 and 30. Same thing at -3. And 4 and -4 get me all the way up to 48, which won't even fit on this graph. So my parabola looks like this. Okay, so we want to actually use the points that we've got there. Number 2, which equation has the graph below? So again, you might be thinking, well, I don't have a graphing calculator. You don't need one. First of all, this is upside down. Okay, so that means there is a negative coefficient here. So I can automatically eliminate B and C because there's a positive 1/2 and a positive 2. Those would be facing up. And so when I look at these two, you probably can't tell the difference just looking at it. The bigger this number, the skinnier it's actually going to be. Okay, and the smaller the fraction, the wider this gets. But what I would do, because you have to have some reference on these numbers here, is just pick any number, like a nice easy number. So I'm going to pick 2 when x equals 2. Plug it into both of these and see what you get. And one of them is going to produce a -2 answer. The other one's probably not going to. So if I plugged it into the first one, -2x squared, I'm plugging 2 in. So it's -2 times 2 squared. Order of operations, I would square the 2 and get 4. And 4 times -2 would be -8. So positive 2 for my x, my answer is negative 8. That would put me down here. So I've already eliminated this one now. It does not fall on that parabola. So obviously this is the right one. Just to show you though, negative 1/2 x squared, I plug in negative 1/2 times 2 squared. So again, that's 4. And then you're timesing that by a negative 1/2. Timesing by a half takes half, so that's 2, and it's a negative. And again, x is 2, it produces a negative 2. You go to x is 2, produces a negative 2. So the correct answer here is letter D. Okay, question 3. We are going to complete this table for a parabola without being given the equation. What you should see is I have a 0, 0 here and have a 5 on both sides. So that's a clue that this is the vertex and both sides are going to mirror each other. So if 2 is 20, then negative 2 is also going to be 20. So don't say negative 20. Notice it's 5 and 5. Think about what this would look like on a graph. Doesn't have to be perfect. 0, 0. When I go over to 1 and negative 1, let's count by 5s. 5, 10, 15, 20. When I go to 1 and negative 1, I get 5. And then when I go to 2 and negative 2, so 2 I got 20. Negative 2 wouldn't be negative 20, right? It's going to be positive 20. So I have for 3 and negative 3 the same answer, so that's 45. And for 4 and negative 4 the same answer, and that is 80. Coordinates of the vertex, that's the point where the curve stops and goes the other direction, goes back up, or goes back down if it's upside down. So the coordinates of this vertex is 0, 0. Again, that's not true for every parabola, just the ones we're studying right now. And is the vertex a minimum or a maximum? In this case, you can see that's the bottom of it. That's the smallest point of this function, or the smallest number that shows up for my x and my y values, specifically my y's, because we're measuring up and down. So actually, yeah, it's definitely not my smallest x, right? These are negatives. This is your smallest y. So if this was a maximum, it would look like this. Your vertex is at the top of this graph. It goes forever down. That's a max. And this is a minimum. So my answer here is minimum, because it's the very bottom of the parabola. Okay, number 4. If you have this function, then this point is on the graph. Is that true or false? Here's what you need to do. This is your x and this is your y. Remember, y is the function, which in this case is h of x. But this is the most important part. Here's your x value. That's what you're plugging in. This needs to be what's produced on the other side. So I'm plugging in negative 3. We want to find out, does 72 come out as the answer? So if I do plug in negative 3, it's going to be squared and then multiplied by negative 8. Negative 3 squared is positive 9. Negative 3 times negative 3. And that's going to get times by negative 8. So I should get a negative 72, not a positive 72. So this point is not going to be on the graph. This point would be negative 3, negative 72. So to answer the question, true or false, this is false. And number 5, if this point lies on the parabola with x equals 0 as the axis of symmetry, so we haven't used that on this page yet, axis of symmetry is the line that cuts these parabolas perfectly in half, and they're symmetrical. That's where the symmetry comes from on both sides. This is symmetry, the fact that we have the same number being produced on both sides, so the parabola is the same. So if we have the point 5, 11, so again, think about this as a graph. Maybe it hits at 0, 0, maybe it doesn't. But regardless, if I have 5, 11 over here, and this is my axis of symmetry, that means I'm going to have the same point over here. So in terms of my y here was 11. That's how far up it was. This one's also going to be 11. But my x value instead of positive 5 would be negative 5. So it's asking to give the coordinates of another point on the parabola. Okay, we don't necessarily know that it's 0, 0 here. What we do know is that if this is the symmetry, it's going to be the same distance on the other side. And so the one point that I do know here is negative 5, 11. All right, and we are moving on to 9-2. So solving some equations where we have an x squared. So the last thing we're going to do is take the square root. And do remember, when you take a square root, it's the positive and negative. We're going to give the exact answers. So that is simplest radical form, meaning no decimals. We're not going to plug these in. If we get a nice whole number, then we keep it. We don't have to leave it as a radical. But if we're going to get a nasty decimal, we're going to simplify the radical. So first thing I'm going to do here is get that x by itself. So I'm dividing both sides by 5, leaving me x squared equals 20. I'm going to square root the 20. And whether it's on your phone or whether it's on handheld calculator or it's on your computer calculator, you should have a way to take a square root. Square root of 20 is a nasty decimal, so we are not leaving it that way. It didn't tell us to round. And so we need to simplify this. The possible answers could be just radical 20 if you can't break it into pieces that simplify. But I know I can break this into a 4 and a 5 because 5 times 4 is 20. And the reason that's important is because the square root of 4 is 2. Square root of 5 is nasty and I can't split it up. Final answer is 2 radical 5. And remember, when you take the square root, it could be the positive or the negative. So it's plus or minus 2 radical 5. You might have seen the 20 and said, well, I can split that into 10 and 2, right? Yeah, you can. This is not incorrect. These are equivalent, but this isn't simplified. I can't do anything here with the 10. It doesn't have a nice square root. I can't do anything with the 2. It doesn't have a nice square root. Okay, so I'm looking for those perfect squares like 4, 9, 16, 25, 36, numbers that have nice square roots. All right, moving on. Divide by 12 to eliminate that coefficient. So now I have m squared equals 96 divided by 12 is 8. We don't want m squared, we want just m. When you take the square root, it's a positive and negative. Square root of 8, we should know that that's not a perfect square. If you don't believe me, plug it in, you get a nasty decimal. So we're either going to leave it as plus or minus the square root of 8, but if we can split this into pieces, one being a perfect square, then that's what we're going to do to simplify. And 4, again, goes into 8, and 4 is one of those magic numbers because 4 has a square root. The square root of 4 is 2 because 2 times 2 is 4. So this becomes whole number 2. The square root of 2 is a nasty number, and it's 2 radical 2, positive and the negative. Okay, number 3, one little extra step here. We're trying to isolate t squared. You're going to save the divide by 4 for last. So we're going to minus 42 here on both sides. So we're doing 67 minus 42. And we're going to get 25. So 4t squared equals 25. I'm going to divide by 4. 25 divided by 4, 6.25. So t squared equals 6.25. And now that t is isolated, t squared is isolated, I should say, I'm going to square root this. Remember, this will be a positive and negative answer. If I take the square root of 6.25, it is just 2.5. So since it's not a whole number, but it's a nice decimal that I don't have to round, this is the exact answer. It didn't say you couldn't give a decimal answer. It says give the exact answer. 2.5 is the exact answer. These other ones would be decimals we would have to round, so they are not exact. Okay, so just because it says exact doesn't mean you can't put a decimal. If it's an exact decimal, we're good. But don't forget also the plus and the minus. Okay, number 4. Now we have a little bit different situation. We have a quantity being raised to the second power. We can still get rid of that power by taking the square root, but we want to isolate this power. So what we want to do first is actually get rid of this negative 2 that's being multiplied times the power times the quantity. So I can divide by it to get rid of it. And so 1058 divided by 2 is 529. And yes, I know these were both negative. 2 negatives make a positive though, so I'm going to get a positive answer. So I'm still left with 3x plus 7 squared equals 529. Again, I divided. Now that I have this power isolated, I can take the square root of both sides to eliminate that power, which is going to simply leave me 3x plus 7, no more power, equals positive and negative version of the square root. So when I go to square root this, probably don't recognize it off the bat, but the square root of 529 is a nice number. It's 23. So plus or minus 23. So 3x plus 7 could equal negative 23. 3x plus 7 could equal positive 23. In these specific situations, you have to solve it differently for both, or separately, I should say. So 3x plus 7, it can equal negative 23. 3x plus 7 can equal positive 23. And then you just solve those little two steps out. So minus 7, minus 7. So I'm going to get negative 30. And 3x divide by 3, and that's negative 10. So x equals negative 10. Or the other option, minus 7, we get 16 equals 3x divided by 3. Does not work out nicely, but an exact answer is a fraction. Don't take that decimal and round it. If you do 16 divided by 3, you get a decimal that needs rounding. But this is an exact answer. So x equals 16 over 3. A fraction is an exact answer. If that fraction could have been simplified itself, we would have simplified that fraction, but 16 over 3 is fully simplified. All right, that's about the most difficult stuff you're going to see in these. The word problems are actually pretty straightforward at the bottom, so this is what you need to focus on going into the test. You will see one of those. Okay, number 5. Looking at a table of values for the function f of x equals negative 2x squared. So where they say f of x, they're actually talking about negative 2x squared. These are the answers that are produced for this function when this x value is plugged in here. So these are the numbers getting plugged in, and then we're going to run them through this. So if you plug 0 in, 0 squared is 0, times negative 2 is 0. So I got this. If I plug in 1, 1 squared is 1, times negative 2 is negative 2. Same thing over here. But we don't have to run it. It's already done for us. I just want to make sure we understand it. So the question's being asked right here. When does this happen? Okay, so when does this function produce negative 18? Well, right here, it also produces it right here. So it's basically asking you, what are the x values that produce the answer of negative 18 for this function? So my answers here are positive and negative 3. You could say 3 and negative 3, or you can write it like that. Okay, number 6, y equals 3x squared, shown here on the graph. Put stars where this is true. So this is all of the function, all the different values of x producing something else. Where does this function produce the answer of 12? So here's 12. Y equals 12. There's the line. So right here and right here, the function equals 12. So what are the solutions? They're asking for the x values. And so we're at negative 2 and we are at positive 2. So plus or minus 2. Number 7. We're dropping something. The water is 42 feet from the top. How long will it take to hit the water? So we are using our formula d equals 16t squared, where d is distance, t is time, feet and seconds. This will be given to you on the quiz. You should memorize it, but it will be given to you on the quiz. And so they have to give you one of the two variables, either time in seconds or feet for the distance. And you just plug it in and solve for the other one, pretty much. So how long, we're looking for the seconds, would it take to go 42 feet? So we're plugging in for distance. 42 goes in for d. We are solving for how long? We are solving for t. So we're trying to isolate t squared, take the square root. So we're going to divide by 16. So 42 divided by 16 I get this. So not a perfect decimal, but that's not rounded. That is an actual exact answer. So t squared equals 2.625. And I need to square root this to get t by itself and get my final answer. So I'm going to take the square root of 2.625. Okay, now this answer does need to be rounded. If you notice, it says about how long. So that was a clue that you were going to have to round this. So we are going to say about 1.62 seconds. Rounding there it didn't tell you how to round, so you can round that different ways. Number 8. We are standing at the top of a cliff and dropping a stone, so we are using the same formula. I'm going to just skip here. She hears the splash in 4 seconds. That's t. How high, how far did it drop? That's d. So we have t. We're trying to find d. So d equals 16t squared. Plugging in for t, d equals 16 times 4 squared. Again, 4 went in for t because that's the time in seconds. 4 squared is 16 times another 16. 16 times 16 is 256. Final answer. Number 9 kind of goes back to Pythagorean theorem. I'm going to draw this picture. She's got a 14-foot ladder. She needs it to reach the top of her 10-foot tall garage. So here's the garage. We know that's 10 feet tall. And she's got her 14-foot ladder, and she needs it to reach to the top. So she's going to lean it, obviously. She's not going to stand it straight up and try and climb it. She's going to lean it. That ladder is 14 feet long from top to bottom. And so it's going to hit the ground. And they're asking you how far from the base of the garage should she place the ladder. So we're looking for the distance from the bottom of the ladder to the base of the garage. That's x. This forms a right triangle with 10 and x being the legs coming out from the 90 and 14 being the hypotenuse across from the 90. So I'm using a squared plus b squared equals c squared every time I see one of these right triangles. The legs go in for a and b. The hypotenuse, the most important one, across from the 90 goes in for c. So 14 has to go in for c. These two are interchangeable. So a squared or x squared plus 10 squared equals 14 squared. Can't do anything with x squared. Go ahead and, plus. Go ahead and expand this. So 10 squared is 100. 14 squared is 196. Okay, at this point you would minus 100 from both sides. So this goes away. 100 away from here leaves you 96. So x squared equals 96. And finally I can square root to get to my final answer. So I'm going to go ahead and take the square root of 96. Not a perfect number. We're going to have to round it. Now, since we're talking about something real life, we want to get pretty close. We wouldn't say this is 10 feet, right? It's pretty close though. So we don't need to go all the way down. She would never measure this small of a decimal, right? So we'll just round this to 1 decimal since that's what the answer key did. So you wouldn't write 9.7. This 9 would round that 7 up. So it's 9.8 feet. About, again, some rounding there. Last one, number 10. Rectangle has length, so we've got length and width. It says that the length is triple the width. So anytime we deal with these, we've done these before, you're going to call one of your sides x and the other one based off of it. So the length, the longer side, is 3 times as big as the width. So I'm going to call this x, and this is 3 times that. It's 3x. Now before you go and label all the sides and add them all up, that's perimeter. It says area. So they're going to give you the area. Area is length times width. So my area is going to equal 3x times x, multiplying these two together. So 3x times x is 3x squared, right? I add my exponents when I'm multiplying. So x to the first times x to the first is x squared. So area equals 3x squared. but we know the area is 108. So that means 3x squared equals 108. This is the area, and so is this. So they equal each other. Divide by 3 to solve this. So 108 divided by 3 is 36. So I get x squared equals 36. And take the square root. Now, again, I could get a positive and a negative at the square root, but here we're talking about the side lengths of a rectangle, so negatives don't matter. Same thing up here. We're talking about a distance here, so negatives didn't apply. Any of these that we took a square root, we're talking about real life numbers, so the negatives, not that there are negative numbers in real life, but for distances, which is what we're measuring here, distances, we're not going to have a negative number, so we can ignore that. So the square root of 36 is 6. So looking at my two sides, if x is 6, that means this side is 6. So what are the dimensions? That means both sides. So one of them is 6 inches, and the other one is 3x. So x is 6, 3x, 3 times 6 is 18. So the two sides of my rectangle are 6 and 18. Again, the last question always tends to be more of a challenge question, stretching you a little bit. So if you didn't quite get that on the first try, no worries. Hopefully you understand it now.